Yeah. Okay, that's it. Let's start then. Okay. Thank you everyone for coming. Today I'm going to explain a little bit about security for your microservice-based applications. Basically, we are going to introduce older concept, security concept, frequently used to improve the security of applications, any kind of application, web application. But in this case, I'm going to use that same concept, security concept, to improve your microservice-based application. Basically, focusing on encryption, encryption or security in transit for your microservices application. Okay. Okay. Well, this is the DevOps Playground. That is a group to support different initiatives around DevOps. And in this case, basically, they are supporting to introduce and explain this concept, how to use Mutual TLS authentication to improve the security of microservices. If you need anything, you can reach me in Twitter, LinkedIn, or through my personal blog. Okay, that a quick introduction. We are going to use TLS to protect communication between different or two parties during the communication in order to guarantee the confidentiality and integrity between both parties. During this playground, you will learn what one way, two ways, or mutual TLS are, how to use a public key certificates or and key material in order to improve and configure your microservices, and how to use mutual TLS together for security communication among microservices. Okay, let's start. First of all, I'm going to introduce what is TLS. TLS is basically is a predecessor of security socket layer. There are cryptographic protocol designed to provide communication security over a computer network. We are going to use TLS to over in this case over HTTP in order to encrypt the communication between both entities, my client and my server. Okay, you are able to use TLS over different layers. You can implement TLS over TCP, over UDP, but the most scenario to use TLS is over HTTP. That is the right scenario, the most used scenario when you are implementing microservices or distributed web application. Okay. Okay. What is one-way TLS? Basically, one-way TLS is a protocol to where the unique entity to be authenticated is the server. When you establish communication between your client against your server provides a credential. That credential, they are certificate, public key certificate, and that credential is going to be validated during the definition of your handshake or your communication. The entity in this case, the entity who is going to validate that credential is your client. The client receive the server certificate, get the server certificate, and validate the server certificate using the available certificate authority. If the server certificate is self-generated, the unique way to validate the certificate is validating cryptographically or using a special routine in order to validate the integrity of that credentials. Okay. Two-way TLS. Two-way TLS, the unique difference between one-way and two-way TLS is we are introducing a new element. The new element is the client certificate. The client certificate is sent to server, and the server receives that client certificate and validate that server certificate against the certificate authority. Then, in this way, you can establish and use this or take advantage of that handshake in order to improve the security of your application. Using two-way TLS, you are able to enable or activate a mechanism to authenticate any client which want to connect to your server. Okay. Then you are using TLS. You can use then one-way TLS. That is the most used scenario or use case available in internet. You are connecting a e-commerce portal. You are using obviously one-way TLS to validate the server. But if you want to connect to the server and activate extra protection, you probably need to configure your server in two-way TLS. In this scenario, you have to issue a new certificate for your client in order to be used as your credential to be authenticated against that server. Okay. Well, what is the security approach which we are using in this scenario? We are using two strategies basically. We are generating certificate. We are generating keys, a private keys, a public keys for my server and for my client. For that reason, we call that approach like a identity-based approach or security. That is basically the first element we need to generate in order to implement that mechanism of security. The second approach we are using is trust-based security. That means we are trusting over my certificate authority as the maximum entity to validate all generated certificates. Okay, in cryptography, a trusted third party (TTP) is an entity which facilitates interaction between two parties. In this case, my consumer, my client, and my server. My client need to trust over my server using my certificate authority. Okay, that is called, for me, in my opinion, that is call it minimal viable security, because using TLS, it's possible to implement security, not 100% of security. Basically, it's the most, you mitigate the most scenarios, the most requirements of security for your application. Okay, it's not necessary to implement VPNs, antivirus, or other security controls. Only using TLS, you are able to implement security around 80% of security, basically. For the reason it's called minimal viable security. Okay, okay. Let's explain this concept using this exercise. I define two exercises. I'm going to jump this. I'm going to explain this. Basically, we have three laboratories. And the first one is a simple Java application which is going to use self-signed certificate. The second exercise or second laboratory, we are going to use a Go simple application, microservices in Go, which is going to use a root CA and intermediate CA. They are going to generate certificate for your server and for your client. Okay, that is a simple scenario where I'm going to explain the concept of one-way TLS and two-way TLS. Okay, that's it. Let's jump to the exercise. In order to do that, I recommend you take your assigned panda, sorry, and connect to your terminal, web terminal, or your code server. Then, if you are registered through Meetup, you have to use your user Meetup user to get that both URL for Way and for your code server. Then the idea is in my case, I use the, let me check before. Okay. Okay, this is the URL you have to follow in order to go through the whole exercise. Okay, that URL is available in Meetup page and in the YouTube channel also. Then take and copy the URL, paste in your favorite browser, open, and once got your assigned panda, you have to take that URL and open that URL in your browser. Okay. In my case, I have Sweet Panda. Okay. In my case, Sweet Panda. Probably you have a different one. For example, Funny Panda, or I don't know what exactly is your panda assigned to you. Okay, you have to take your panda, open the panda, okay, copy the URL, append Way Tl at the end of URL, and copy the URL in your browser. Okay, in your browser, open your browser, paste there. Okay, in my case, it's panda. I already opened in this tab. Okay, I'm going to launch. Okay, let me reload this page. Okay, using the form, the page you have available in Meetup or in YouTube channel, you have to take and open that page, Panda page, and get the URLs. In the same URL, you will get the password also in order to get your Weti open. That's it. That's it. Increase the font size. Okay, we are ready. Then, okay, I recommend to open two tabs for that for Weti. Okay, I'm going to open a new one. Because in one terminal we are going to run the server. In the other terminal we are going to run or perform request. Okay. Okay, that's it. Okay. Once open it, the first Weti terminal, okay. Yeah. In the first Weti terminal, you have to introduce all commands available in this GitHub repository. Okay. Okay. Then in this page I explain how to get your Weti terminal and how to get your code server online. Okay, I recommend to update the prompt of your Linux terminal. For the reason I download this bash script to automate the changes in your prompt. Only once log in, paste the command, previous command, this command, copy and paste here. Okay, hit enter. That will update your prompt. Copy the second command. Okay, again paste there. Copy again the next command. And the last one also, copy and paste there. And that's it. Okay, that's it. That is more comfortable for you in order to introduce and execute more commands, longer commands there. Okay, that's it. Let's execute quickly. The first laboratory is one grading Java. Okay, click in that link. As I mentioned before, we are going to run and test this scenario. Okay, we are going to run this Java application. Okay, load and configure TLS and load the certificate, and using code to call the microservices over TLS. The first example will be one way TLS. The second example will be second or two ways TLS. In this first example, we are going to use self-signed certificate generated with Java key store. Okay. Okay, let's start then. Okay, what else? Okay. Yeah. Okay. Okay, better. Okay. Okay, that's it. Let's start to introducing all commands. The first things to do is go the current directory for that laboratory, copy the first command and paste in the first terminal. That's it. Okay, let's check the configuration, the current configuration of my microservices. Okay, copy the command. You will see server and port 1919 running in 1919. That is the simple configuration. Okay, for my microservice, no TLS, no encryption, no security. Okay, the next step is run Maven clean Spring Boot to run my microservice in Java. Okay, paste there, hit enter again. That command will download all dependency for my simple microservice and will run the service there. Okay, that means the server is running. Okay, let me resize them a little bit more. Okay, that means that the service is running. Oh, now in the second Way Tl terminal, okay, in the second Way Tl terminal, okay, this is not going to work. Okay, in the second Way Tl terminal, we are going to run this command. This is cool command. That command is going to perform a request my existing running service. Okay, paste there. Okay, that's it. That means my microservice, my simple microservice is running. Okay, make sure, that is very important, make sure you change your working directory. Actually, my working directory in the second Way Tl terminal is playground. We need to change and go in the working directory for that example. Okay, just copy again the first command and paste in Way Tl terminal. That's it. Okay. Okay, in the first Way Tl terminal, my microservice is running. Just Control C to stop. Okay, the services, and let's continue it. Okay, that's it. Now in the second section, we are going to configure my microservices to use one-way TLS. Okay, to do that, we have to generate certificate for my server. To generate certificate in my server, we are going to use key tool, a Java key tool. Just copy that command, and paste in the second Way Tl terminal. Okay, make sure you have to be in the working directory. Okay? Okay, then copy the key tool command and paste there in the second Way Tls terminal. Hit enter, and that command will generate a certificate, a self-signed certificate for your microservices. Okay? What else? Okay, next step is updating the application. Okay, the application. That application .yaml is the application for my microservices. Okay, we have to update that configuration using that details. We have to run microservices in that port. We have to enable TLS using that flag or that parameter. We need to provide on my microservices where are my keys or where is my certificate. In this case, I already generate my server identity P12 in that specific location. Now we are going to check that. We have to provide also the password in order to open the file, the P12, because P12 is encrypted or secure using a password. And we need to provide also other password, because the other password is to open and use the private key included in the P12. Okay? Then, in order to edit this file, we have to use the code server. Okay? The code server should be open in other tab of Windows of your browser. Okay? The Way Tls is a Visual Studio Code running in mod server. Okay? Mod server. Okay, let's to resize that. Okay, you have to use your assigned URL for your provisioned workstation, remote workstation. In my case, it's SweetPanda, DevOps Playground org, in that running in the port 8000. Okay. Okay. In my case, it's already loaded. In that code server, you will see the project. Okay. Just go at the right directory. In this case, we are playing with the one great in Java application. Go to source, CRC, go to main directory, go to resource. Under resource, you will see application.yaml. That is the application for your microservices. In the same folder, you will see the server identity P12, which was generated with the previous command, key tool command. Okay, click over server identity P12. Obviously, you can see that file because that file is protected for one password. Okay, doesn't matter. We have to only update the application.yaml file. Okay, we have to override that details, that configuration, using that configuration in the step number 2. Under step number 2, update the REST service configuration file. Just copy the command, the details for application.yaml and paste over the file. Okay, that's it. That automatically will be saved. Okay, again, go back to your first Way Tls terminal and run again your microservice. Okay, just you with using the arrow up, you will select the previous command. Okay, the previous command in this case will be maven clean spring boot run. Just hit that command. That command reload the configuration and execute your microservice. Okay, that means it's running. Now, using again the second Way Tls terminal, we are going to execute code to call that microservice. Okay, go to the next step, run the REST services and test one Way TLS connection. Okay, only copy that command. That command is going to perform a query for that specific microservices using the flag -- insecure. Okay, because that flag allows to occur to make calls over TLS with certificate validation. Okay, just only for testing. Paste the command in the second Way Tls terminal. Okay, and that's it. Okay, you will see that message, which means that your microservice is running over TLS using one-way TLS. Okay, in the header, in the logs, you will see all handshake performed between your client and server. Okay, you will see this is part of the handshake client hello, server hello, certificate status, blah, 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 blah. That is basically show all details when your client and service are establishing communication, secure communication using TLS. Okay. Okay, I can remove -B. Okay, and you will see only the payload, the response. Okay, that's it. Okay, we can use instead of -- insecure, we can use -K. Okay, that's it. It's the same. Okay, that's it. What happens if I remove -K? Okay, let's hit that. I got a message saying could fail it to verify the legitimacy of my server. Okay, obviously that means my client, the core, cannot validate the server certificate. Okay. What else? Cannot get validated the REST service TLS certificate because the client don't have or don't trust the CA that issued the server certificate. You know, that server certificate is a self-signed certificate. Okay, let's get the certificate of the server and pass it to core using the -CI cert. That is a special parameter to include in the core command in order to pass and or define what is the server which core trusts on. Okay, then you know I generated the P12 certificate before. Okay, this is a secure file that is in P12 format. Okay, we need to perform a special command in order to extract only the the server certificate. To do that, we have to perform that command, key tool. Okay, this command is going to extract only the server certificate and save that server certificate in that file, in that path. Okay. Okay, let's copy it again. That command, copy in your second waiting terminal, paste that command, the previous command, paste and hit enter again. Okay, that certificate or that file was generated in that path. Let's check using code server. Okay, there is there, server CRT. Okay, surprise, that server CRT is in pen format, the most used format for my to share or manipulate keys and key material. Okay. Okay, that's it. The server certificate we generate in that path. Okay, that's right. Now we are ready to execute again curl command using CAssert flag using the previous generated certificate. Okay, let's do it. Copy the command. Okay, check your microservice is running. In the second waiting terminal, paste the command, previous command. Okay, paste there and hit enter. And again, you got the same error. That error is related to trusted store certificate or a trusted certificate store. That is a special repository where the Linux box or the core or your browser, as you are using browser, store all certificate which that browser tool or Linux box is trusting. Okay. In order to use that repository, that special repository of trusted certificate, in this case for core, could need to be compiled from scratch and use a special configuration to use that existing trusted certificate repository or store. Okay, I put that link or reference if you want to test that in that GitHub repository. Okay, let's jump on the next steps and let's use or enable two-way TLS. Okay, again, we are going to use a key tool to generate an extra certificate. In this case, that certificate is going to be for my client. Okay, that certificate for my client is going to be self-signed certificate again. Okay. Okay, copy the next command again. Copy the command in your second waiting terminal, paste the command, hit enter, and that command will generate a new certificate for my client. Okay, that certificate is named client identity P12. Let's check. Okay, using code server again. Code server in that same repository, sorry, in the same folder, resource folder, you will see the client certificate. Client certificate is client identity P12. Obviously, is encrypted. Okay, like server identity is encrypted. And now, in this case, client certificate is going to be used as credential or factor to use during the authentication or during the establishment of the communication with my server. Okay, my server is going to ask for my credential, and the client is going to send client identity P12 in order to be authenticated. Okay. Okay. We need to extract, obviously, the certificate like we did for that server. We need to get only the client certificate. Client certificate is going to be my ID, my credential, to be presented against the server. Okay. Then we need to extract the client certificate from my client identity P12 using that command. Again, copy the command and paste in Way Tls terminal. A second Way Tls terminal, clear, clear, again, paste there. That's it. Let's check again with code server. You will see client CRT there. Okay, obviously it's in pen format. Okay. Again, let's try create a transistor for my server. Okay, that is required for my server, for my microservice for Java. Okay, to create that transistor, we are going to use a key tool. Okay, key tool, copy the command, again, second terminal, paste there, hit enter, and that GK8 format or file will contain all trusted certificate. Okay, let's check again using code server. You will see the file here. GKS is a special format for my Java application. Okay, that file contains all trusted certificates which are necessary to run my server, my microservices using TLS. Okay. Okay. The next step is configure my application, my microservices. Obviously, we need to update that file. And in order to do that, copy again the command, copy the command, and let's to overwrite the application.yaml file, which was opened before using code server. Okay, you will see the previous configuration. Just delete and paste again the new configuration. Under the new configuration is under step number 4. Okay, that's it. Once done, Control-C in your first Way Tls terminal to close, to stop your microservices, and run again, maybe clean Spring Boot run to execute and reload the existing configuration. Okay, that's it. That's it. That means you're running your microservices. What else? Okay, we need to perform a previous step. Okay, we need to convert my certificate in a special format which could require. Okay, the next key tool command only is necessary. The step number 5 only is necessary if the previous key store file was generated in GK8 format. In our case, all Java key store files, client identity P12 and server identity P12, were created with the destination store type PKCS12 flag. That means it is a format, a special format for my to store my private key and public key, right? Then that is only necessary if you are generated that format in GKS, but that isn't our case. Okay, just jump to the next command, next step. Okay. Okay. Finally, you are able to call the microservices. Okay, to test the Mutual TLS. Is running, my microservice is running. Only copy the next command, the cool command, which -key, in order to bypass the server certificate validation. Okay, paste there. Okay, you will see we are using the server already generated, full qualified domain name. Okay, it's not there. No, yeah, sorry, it's not there because we have to generate it. Okay, let's check. Okay, obviously it's not there. Client identity is not there. Qualified domain name. Okay. Copy. I'm going to change the command. Yes, I remove full qualified domain name. Okay. Paste again. Enable to set private key. Okay. Pen format. Okay. The pen format file hold the no sir. Okay. Okay. I'm going to extract the client identity pen. In the previous steps, we jumped or bypassed the execution of OpenSSL in order to get the performance of my client identity required for the next command. Let's copy just that command and paste there. In a second, in Way Tls. Okay, that's it. Let's check again. Pen format, yeah, client identity pen format is there. Okay, since that is private key. That is private key. All private key need to be encrypted. Okay, that means it is being generated in right format. Okay, that's it. In the first Way Tls terminal, we have to restart the server. Okay, it's there. Okay, let's execute again that command. I think it is not going to work. Anyway, let's check. Paste there. Okay, it's asking for my password. You know, the private key which we are using here is protected by password. That password need to be introduced here. The password is secret. Okay, that's it. Okay, that means my client I establish secure communication with my server using Mutual TLS. My server is asking for the credential to the client, and client is presenting that client certificate to my server. In order to get authenticated, my client need to demonstrate the client holds the private key. To get access to the private key, the core asks for the password. That is a simple mechanism to establish an authentication protocol between client and the server, only using TLS. Okay, obviously, we are using self-signing certificates for Java application only, but that is only for testing purpose or for demo, a private demo. That is obviously is not a recommended option if you are working in production. When you are working in production, you have to use other tools in order to automate all processing and avoid the generation of keys manually. Okay. Okay, testing TLS using a client P12. Yeah, that is not necessary because you can. We are using different command here and passing that secret, the password, okay, in the curl command, and avoid to prompt or ask me for the password from the command line. Yeah, okay, we can bypass these steps and go to the second example. Okay, the second example. Okay, let me expand. Okay, the second example is the same scenario. Instead of using Java, we are going to use Go. Okay, and instead of using self-signed certificate, we are using a CA. Okay, a root CA and intermediate CA. The root CA generate the intermediate CA, and the intermediate CA generate or issue certificate for my server and for my client. In this case, curl. Okay. 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 Go the GitHub repository. Go the root of the GitHub repository. You will see Hello World example or lab. Hello Go. Okay. Click over there. Okay. In this case, I prepare a bash script to generate all certificates for you automatically. It's not necessary to perform all commands like we did in the previous example. Okay, we are going to use this bash script, open gen cert sh, to generate all certificates, root, intermediate, client, and service certificates using OpenSSL. OpenSSL obviously is the most used tool to manipulate certificates and keys in Unix, in Linux also. Okay, this is a little bit different of Java key tool. Okay, it's more it's available in different distributions of Linux, even in Windows. Okay, okay, let's use that shell to generate that certificates. Okay, again, reconnect. Okay, okay, clear. We have to go working directory. Just copy the first command in your first web terminal and paste there. Okay, we are ready in the mTLS application example to Hello World directory. Okay, in that directory, we have to execute the second command. We are going to clean all existing or temporary files in that. Just paste the command, open SSL gen cert.sh cleanup, hit enter. That's it. And the second command, again, that second command will create all certificate for you. Okay, that is going to generate many certificates and private keys and public keys and root, the intermediate for generic name, in this case localhost. Okay, using secret for all private keys. Okay, hit enter. Okay, that's it. That's it. We can use 3 dots to explore all certificates or files generated for the previous bash command. Okay, as you prefer, you can use the code server to explore that directories and the files. Okay. Okay, let's continue. Let's configure and play with a one-way TLS configuration. Okay, in that, okay, yeah, in that step, you have to copy the first command. This is first command running the microservices. Okay, just copy and paste in the first Way Tl terminal. Okay, that command will run your simple Go application, hello Go, okay, in using localhost as domain. Okay, that's it. Now copy. Before doing that, change your working directory in the second Way Tl terminal and copy again the first command. Okay, copy the working directory, paste again the second Way Tl terminal, ready in the second Way Tl terminal, execute the curl command. Okay, the curl command. Curl command is this. Copy the curl command, paste there. That command is going to call your previous microservices in Go using the certificate, the intermediate certificate, and using that endpoint, localhost, and that port 19443. Okay, is going to be used for that microservices. It's not running there. Correcto. Okay. Case again is closed. Okay. 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 Go working directory. Run your microservices. Okay. Now in the second Way Tl terminal, again, execute the curl command. There. You will see hello world. That means your microservice is running in that port, running one-way TLS. We already generated certificate. One certificate for my server also is configured in that Go simple application microservices. I'm using the second terminal curl to perform a query at the existing running microservices in Go. Okay, that's it. It's simple. Now in the next step, we are going to enable and configure two Way Tls. Just again, copy the next command. Okay. Previously, we have to close this filing. Oh, here, my password. Okay, that's it. Okay, clear. Okay. Go the working directory, paste the command there. Okay, execute the command. In this case, we are going to enable Mutual TLS. Okay. Now, the second Way Tl terminal, execute curl. But in this case, we are going to use the certificate already generated for that microservices. I'm going to use the client certificate. You will see under client folder, the client certificate, and we are to use the private key. already created in that folder, that client folder. Okay, that is the unique difference between Mutual TLS and Way TLS. The second command, we have to use the private key. Yeah. Copy the command, paste that in the Way T terminal, and go. Connection refused because probably it's closed. Yeah, yes, closed. Okay, again, execute again. Okay, clear. Okay, working directory. Okay, running the microservices. Okay, execute the command. Paste phrase, secret. Is working. Okay, that is working. That means my microservice is running over TLS and asking for client authentication. In this case, the client have to provide a credential, a client certificate to the server in order to be validated. Okay, it's very similar to Java scenario. Okay, that's it. That's it. It's more simple because I generated previously the certification. In this case, you don't need to generate that certificate manually. Okay, the unique difference in both scenarios, the difference in both scenarios is in the second one, you are using root CA and intermediate CA. In that first scenario, in the first lab, you are using self-signed certificate for Java. They have different tools to generate certificate and different strategy to configure the keys and load the keys for that different applications. Okay, obviously that is not the right way to do that, because what happens, you have 100 of microservices running. That is a little bit complicated. Run one by one and generate all certificates for all 100 microservices. That is complicated. We need to look for some strategy to provision, automate the generation of keys and certificate, and load dynamically all TLS configuration. Self-signed certificates are for testing only, but definitely it has much more problem than benefits. We need to introduce a new component here in this scenario. We need to introduce a PKI. PKI is a services to provision certificate for all workload, microservices, server, mail server, FTP server, and so on. Okay, yeah, you have a bunch of solutions available, open source and commercial in the market. Yeah, okay, you can grab your preferred or favorite solution to generate certificate. Okay, there are many. The keeper and certificate provisioning. Okay, the key case certificate provisioning and its configuration depends on program language. Yes, that is right. You are using Java, well, you have to know how to configure your keys or how to load the certificate for Java application. That is a little bit different for PHP application, Go application, or other kind of application. You have to use a special format, a special repository to store the keys and share the certificate. Yes, that is the most common scenario in any organization. You have different teams working in different language, implementing different use cases. Then you have to provide an agnostic way to implement and deliver this kind of implementation. So you want to implement TLS for Java, that should be the same approach to use for Go, for Python, or for Node.js, for example. Okay, we need to look for some strategy to cover this gap, this problem. Okay, that's yeah. The cert keeper life cycle. Yeah, what happens is the certificate has a time span for 1 year. What happens when they pass 1 year? You have to generate a new certificate, and you have to take out your existing application, configure the certificates, and deploy again the application. We need to look for some strategy to deliver the keys in automatic way, avoiding to stop my existing services. That is a problem. Okay. Then, for the reason, there are many solutions in the market what helps to support the delivery of keys in real time, during even in production. Okay, we need to consider this kind of strategy in order to cover this gap. Okay, the TLS configuration and key distribution are manual tasks. You seeing in the previous labs, in labs 1 and labs 2, I generated the certificates and placed that certificate in that specific folder. What happens if your application is using different structural folder? I have to take and grab that files and keys and certificates and move that certificates to other folder. That is not right way to do the things. We need to think in a special mechanism to provision and assign or deliver that keys in that specific folder structure which your application requires. Okay. Yeah. Initialization and distribution of configuration and keys must be part of your CI/CD pipelines to be able to scale. That is the key. We have to scale this approach. So you want to implement TLS or Mutual TLS, we need to think this task performed in example 1 and example 2 need to be automated and should be part of your CI/CD pipelines. That is the key. And this is a unique way to escalate the delivery of your application in secure way. Okay, then I would like to explain the second scenario. I am introducing a new concept borrowed from service mesh architecture that's called sidecar or proxy sidecar proxy. Okay, I don't know if we have time to do that. Okay, we can continue with that. Okay, we are going to do quickly. Okay, we want to introduce a new concept here. It's not a new concept. It basically is we are using a tiny proxy, okay, in order to deliver or offload all extra feature of your business application. Okay, you know, configure, enabling, all aspects related to authentication are not part of your business logic. That should be part, or are not part of your business logic. Your microservice should be focusing only in business logic, to implement business logic, authentication, how to enable TLS, how manage the roles, permissions, something like that. It's not part of your business. Okay, then we have to implement that no business requirement, no business feature part of your big application in other extra component in your sidecar or in your proxy. Okay, in this way we are decoupling business and no business. Business for your microservices, in no business feature is going to be in or placed in your sidecar. Okay, sidecar proxy, in other words, reduce the complexity in the microservices code by abstracting the common infrastructure related functionality to a different layer. Okay, we have two components basically. Okay, first component is going to be your proxy, and second component is going to implement your business logic, your microservices. Okay, in this way we can implement and address all security controls using single implementation of your security controls in one place in sidecar. In this way, you can reuse the sidecar and implement that sidecar in other scenario. Okay, in other example, so you are writing your applications in Java, you can put in the front of your Java application that the same sidecar you are using in Go for Go. Okay, this is the best way or the right way to escalate all ecosystem in your organization, application or ecosystem. Okay, reduce code duplication. Obviously, it's not necessary to implement the authentication or how to load or configure TLS in your application, in your business application, because you are going to use or implement that feature in your sidecar. Okay, provide loose coupling between application code and the underlying platform. And this way you can obviously use sidecar like your secure building block and reuse the component in different applications in your organization. Service mesh is a new concept. Okay, it's not necessary to implement service mesh. Okay, you need only to connect your microservices. You need to connect your microservices using a common mechanism based in your infrastructure. Like when you are connecting your services or your server in your LAN, in your local network, you connect many services or server, your web server, your FTP server, your file server, connected in the same LAN. The same LAN, okay, has two elements, main elements. The first element is your infrastructure, your cable, your wire. Okay, using this approach, using proxy and sidecar, basically we are building that layer, the physical layer, and implementing security in that level. Okay, service mesh basically has two elements: the data plane and the control plane. The control plane basically is a control panel which manage all feature in your network. The other component of the service mesh is called data plane. Data plane is your network, is your wire, where your microservices or your workloads are connected. Using a sidecar or proxy helps us to build that data plane. Okay, for this reason, many solutions in the market, like a service mesh, like a STO, like a I don't remember the names. There are many. Um, um, are based on in the simple component called Envoy proxy. All solution, commercial and open source in the market right now are using the same concept, the same tool even, that is called Envoy proxy. But in this case, we are adopting this approach and using a proxy to offload and decoupling the secure or the network requirements in that proxy. That network requirements are not part of your business. The business obviously is going to be implemented in your microservices. Okay. Okay. In that example, we are going to address only one security requirement. We want to implement TLS for my microservices using sidecar proxy. Okay. In this case, we are not going to use Envoy because we need more time and we need to understand the essential concepts and understand the API of Envoy because it's a little bit complex. But we are going to use, in this case, CADI. CADI is a simple proxy suitable for this kind of scenario. Automatically will get or generate certificate for you by default for your microservices. Okay. CADI embed libraries to generate certificates. CADI embed a small step certificate tools or framework inside to generate that certificate for you automatically, or keys. And load that certificate in the memory of your CADI services. In this way, you are avoiding persist the keys or certificates in the file system. Okay, that is suitable for this kind of scenario. You can implement quickly a secure data plane using CADI. Okay. Other things, very important things for CADI implement by default ACME protocol. ACME protocol, you know, is the protocol used to issue let's encrypt or zero SSL certificate. Yeah, you are playing with Kubernetes and use certificate manager plugin extension to get let's encrypt certificate. Well, the same library, the same protocol is implemented in CADI. Okay, then we are going to take that advantage, including libraries to generate certificate, and including that protocol, ACME protocol, to retrieve and fetch certificates for you automatically. Okay, let's start with that example. Okay, again. Okay. Again, open one terminal with the terminal. That's it. Clear. Okay, go. Sorry, it's annoying. Okay. 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 Go back to GitHub repository. Go the root at top of your repository. Select the last laboratory, 3 CADI sidecar. Click over there. It's flowing. Okay, yeah, ready. Example number 3, using CADI as sidecar proxy for microservices. Okay. Okay. Preparation. Let's go the working directory, copy the path, paste in the first waiting terminal. Do the same for the second waiting terminal. I think it's not necessary, but just that. Okay, that's it. What else? Blah blah blah. Okay, that's a command. That's it. Okay, we are going to use CADI as proxy, not as a file server, to expose a sample application. We are going to use then as application, a business application, Quart. Quart is a demo application for Kubernetes up and running, written for Casey Hightower, I think so. Okay, we are going to download the Quart, running Quart in one container, and download CADI image and run CADI in other separate container. Okay. Okay. First things to do is run the Quart as container. Okay. Copy the command, paste the first waiting terminal. That's it. Okay. That command download the Docker image for Quart and run one instance for it. Okay. Let's check Docker ps-a with that -e. Okay, you will see all Docker containers running in my remote workstation. We have already running. Let me extend. Okay, we have 1, 2, 3 containers running there. Okay, one container is Weti. Obviously, Weti is running in one container. Code server is in other. And Quart is that recently downloaded container. Okay, that's it. Okay, okay, that's it. Let's check. Okay, Quart, copy the curl command, paste in the first waiting terminal, and that's it. That means it's running. Okay, okay, you will see okay there. Okay, we are checking healthy URL endpoint. Okay, we can check also using my browser. In this case, we have to use the full qualified domain name assigned to you. Okay, in my case is Sweet Panda. You can copy the URL. Copy the URL. For example, here, sorry, I prefer edit here. Copy the URL and put the port 1970. Sorry. Okay. HTTP, no HTTPS. That's it. Copy there and open a new tab and paste. That's it. It's running. Okay. My core application, my business application, my microservices, anything you are running as application, okay, in one container will be available in that port. Oh yeah, obviously, because we are running my core Docker container and exposing, okay, 1970 port. Okay, that's it. The next step is running my yeah. Okay. Let's run. Okay. Let's run CADI, but using this configuration. Okay. I prepared that configuration in that folder. Using code server, let's explore that configuration, okay? Okay, remember, it's under one basic slash caddy file.example2. Okay, open the file. That file obviously will be in the third folder, 3caddy sidecar under one basic, and you will see caddy file example2. Okay, that configuration is here. Okay, just checking like GitHub page, and that's it. Now we are going to run a caddy instance and loading that configuration. That means we are going to run caddy in localhost 1918 port and going to work as reverse proxy to proxy my QR service running in port 1970. Yeah? Okay, again, copy the Docker command. Okay, under step number 3, paste there, and that's it. Okay, automatically download caddy image from Docker Hub and creating a one instance. Let's check again. Let's check. It's running Docker PS. Okay. Yeah, it's there. Okay, it's there. caddy 3 is running. It's the name of my instance I already created. That is going to work as a proxy for QR. Okay. What else? What happens if you stop waiting? Well, you can run that example at your own pace if you want after that. Okay, that's it. Running caddy as proxy. Now let's to call my quart through the weti. Copy the cur command again with -i k, pasting your clear, pasting your weti. Okay, enter, and that is a error message. Okay, 502. That you check from or using your browser. That means caddy already generated a certificate for you and exposing your microservices or your application over HTTPS, no HTTP. caddy is automatically redirecting your HTTP traffic to HTTPS. In other words, caddy is saying, don't call the microservices using HTTP. Use HTTPS. Okay. When you are performing that command using HTTPS, now the message is different. The site can't provide a secure connection. Okay. Since the caddy is exposing query over HTTPS, we are going to use that URL instead of HTTP. Okay. Let's open the browser, copy the URL. Okay. Okay. And paste again and replace HTTP for HTTPS. Okay, HTTP, and change the port which CADI is running. In my case, it's running in 1990. Hit enter. Yeah, you will see the same error. SSL protocol error. Okay. What is the problem? The problem is the container, the Docker, the CADI container and the QR container are running in different network. We have to use the Docker network instead of use the physical network to and route the traffic from the CADI to the QR. Then we need to move the CADI container and the QR container into Docker network in order to be able to route the traffic, the incoming traffic to the backend. Okay. Then in the step number 5, I explain all commands we need to perform in order to move QR and CADI into Docker network. In this case, I'm going to create a Docker network, call it lab3 net. Okay. Okay, paste there. Okay, copy again the Docker network connect lab3 to add CADI3 to lab3 network. Again, repeat the same command with QR. Okay. Now we can check the network already created. You will see in the details all information about your network that you created. In that network will be QR and CADI3. That is right. Now, QR and CADI are running in one virtual network inside of Docker engine. Okay? If you want, you can perform that command. You can perform a ping command from CADI to QR. Copy that command, and you will see it's possible to reach QR from CADI using the Docker network. Control C to stop that. And let's try to call QR through the proxy again. Okay, in this case, we have to update the configuration, the previous configuration. In that configuration, it will be in CADI file example number 3. Just open again. Again, example number 3, using code server, you will see the configuration what you have to load in your CADI. Oh, close this terminal, it's not needed. Okay, okay, that's it. Clear again. Okay, before we have to remove the already created running CADI3 container. Using that command, check again. Docker ps, sorry, ps. Sorry, again, Docker ps. Okay, it's not there. Okay, let's run again the Docker command using the previous CADI file example 3 configuration. Okay, run CADI again. Okay, that's it. That's it. You will see I'm using the net flag and using the previously created network, Docker network in that command. That with that command, we will include that CAD instance in the same network, which QR is running. Okay. Again, let's check the logs. I copy the command, container ID, and use sudo to make a tail. Again, your password. You will see all logs. That means serving initial configuration, blah, 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 blah. That means it's working, your CADI. Your CADI generated certificate for you, for your microservices of your application, and that is working. Okay, let's check it then. Using cur again, copy the command, paste that in your Way, execute that. That means it's working. Okay. Yeah, you can remove the I and B. You will see. Okay, that means your QR services is running. Okay. Call QR through the proxy from a browser. Okay. We are going to use the browser again. You will see the same error message you got when both containers are running are or not part of the same network. Okay. What is the problem? What is the reason? Okay, let's to check if you want. That is not secure. We have to run that port. Okay, HTTPS and the port 1919. Again, hit enter. Yeah, the same error. Okay. That means the browser cannot load the page because the certificate that CADI generated doesn't match the full qualified domain name used to call the QR services. Okay. I generated a certificate, or in other words, CADI I generated a certificate for localhost, not for Sweet Panda. Okay, we need to generate a certificate, a proper certificate for my microservices. Okay, let's do that. To do that, we need to load a proper configuration. That proper configuration is in the QR. Sorry, in the CADI file example 4. Okay, again, click over CADI file example 4 using your code server and check the configuration. You will see I introduced this command, this configuration, funny panda. Okay, obviously that is not my case because I have a funny panda, sweet panda, and have to use sweet panda in that place. Copy my URL, paste sweet panda. Okay, you can remove the previous funny panda or comment. I'm going to use sweet panda, DevOps playground, or G column 1980. Okay, that's it. Okay, the CADI is going to run as reverse proxy. I'm going to redirect all traffic to QR over 1880 port. CADI is going to generate a certificate for that host. Okay, and my CADI proxy is running in that port. Okay, now I'm going to remove the previous instance of CADI, copy the command, go to your terminal, paste the command there. Okay, CADI remove it, have been removed. Copy again the command, the Docker, command, clear, okay, docker command there, and use the existing updated configuration file. Okay, that's it. Okay, check again, docker ps. Yep, it's running. CAD is running in that port, blah 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 blah. Perfect. That's it. And you can check the logs you want. Okay, you have to see that logs. That means it's working. We are ready to call the microservices again from the browser or your curl command. Just to check with curl, copy the command. Sorry, that is funny panda. We have to use your full qualified domain name. In my case, is sweet panda. Hit enter. Okay, it's working. Now we have to open the browser and use the URL. Okay, in the port 1919 using HTTPS. Okay, I have opened already. Hit enter. It's working. Okay, that is one-way TLS. Okay, that is one-way TLS. Let's enabling two-way TLS. It's that simple. Okay, in this case, we need obviously introduce a new certificate for you, for your client, basically. We are going to use that certificate from the lab number 2 we already did. Okay, let's copy all commands there. Yeah. Again. Okay. Copy CD, go to the lab number 2. Make a cleanup there. Generate again the certificate for the client lab 3. Yeah. Instead of localhost. Okay. We need to extract or convert the format of my certificate in PF or P12 format using OpenSSL. Copy the command there. Now the next step is create 2 directories. Sidecar, custom cert. Okay. Paste the command there. And copy the certificate, the root and C8. In that created directory, repeat again with the last command. That's it. Okay, that's it. Now go back to your working directory, current working directory. This 3 caddy sidecar, hit enter. Check the right configuration to enable Mutual TLS. Yeah, you will see it there. You can open using code server also. Is caddy file mTLS. Okay, you have to make sure you have to replace your panda for your panda. Okay, in my case is sweet panda. Copy that and replace sweet the variable. Okay, that's it. That's it. What else? Now again, we are going to create a new instance. Instead of remove the previous one, we want to create a caddy 4 instance. Okay, in the same network, lab 3 network. Okay, Okay, paste. That's it. Created. Let's to check. Docker PS. Yeah, we have KD3, KD4, and running Quart as my business application. Okay. Okay, that's it. Time to test that. Okay. Step number 4, call the services and check Mutual TLS. Okay. That is very important steps to perform there, because that step allow us to use the certificate, give the right permission to read the certificate, because CADI perform generate certificates and load the certificate in memory. But in order to download the certificate, the C8 or the root certificate generated for the server, I mount that folder using Docker. For the reason I need to give permission to read that files mounted for Docker. Okay, then just copy that command and paste in your Way Tls terminal and execute that. That's it. Now we have to copy that command. Instead to use obviously funny panda, we have to use or replace for your panda. In my case is sweet panda. Sweet panda. Sweet panda. And that's it. Copy the command, paste in your Way Tls, and you are ready to execute again the cur command. Paste the command in your Way Tls, and that's it. That is working using Mutual TLS, providing client certificate, client private key, calling to Quart through my Docker container containing obviously CADI as proxy. Okay, we can do that same process through the browser. Okay, we need to update the URL and change the port name. Okay, we are using 1991. Just change the port in the browser, and that's it. We got an error because my browser need to load a present the client certificate. Okay, could have the client certificate in the command, but the browser doesn't have that certificate. Okay, then okay, that's it. We can download the certificate and install in my browser. The certificate will be available in code server, through the code server. Okay, so you follow the picture, the screenshot available in the GitHub repository, you are able to download the certificate following the same steps. Okay, the certificate will be under Hello Go. Okay, Hello Go. Go to Hello Go. Go the clients folder. Download. Open search certificate folder, and you will see client lab 3 PFX. Okay, this is a P12 format. Just download that certificate using or making a right click over there, over the file, and download the file. Okay, taking time. Okay, that's it. Okay, that's it. Client lab PFX, save there. Okay, I'm going to open. Showing folder. I have Windows, okay, but probably you have to perform different steps in your computer because you have Linux or you have Mac. Well, but the step, in other words, will be the same basically. Will change the format or other windows, but only in my case in Windows, I have to make a double click over the file, and that will be installed following the wizard or install pfx. Okay, you will see this mechanism to import the certificate, that wizard to import that certificate. That certificate is P12 format that contain that public key certificate, the public key, and your private key. That P12 or PFX file contains all three files, and that is secure or encrypted or protected for a password. Okay, that's just follow the installation. Obviously, that is going to no mark key is portable, protect private key. Okay, no, that's it. Okay, just enter your secret password. This secret in this case. Okay. Next, automatically select the certificate stored based on the type of certificate. That is your credential. That should be your personal credential that need to be in secure repository in your certificate store. Okay, that's it. Finish. Okay, that means it's already imported. Okay, that's it. Now it's time to reload the application again. Okay, you will see a new window asking to select your credential. Okay, do you remember I in using Curl, I provide the key as a file, but using the browser need to provide that file in some way. In this case, I need to select from my certificate repository the proper credential to present or send to the server. In this case, is client lab already created. I can check the information about that certificate. You will see the certificate there. All detailed certificates will be there. Issue, who generate or issue that certificate, the validity, what else, subject key, yeah, all the data of the certificate. Yes, okay, select the certificate and click over OK. That's it. Okay, that is running. That is Mutual TLS authentication using CADI, which generated automatically certificate for you using ACME protocol, load the certificate in memory, and working as reverse proxy for your application in this case. That's it. That's it. Okay. That is the most important things to do when you are trying to implement security, minimal viable security for your microservices. Try to use, in first instance, TLS to enable security for your application. Okay. Use Java, Keytool, or OpenSSL to generate certificates only for testing purpose. That is not production ready. It's not recommended for production. For production, you need to escalate. You need to embed and perform different procedures or tasks, generate certificate, load the configuration, retrieve the certificate, okay? Massively for your 100 or 200 microservices that need to be orchestrated from your CI/CD pipeline. Okay. Then, for the reason we are adopting sidecar proxy in order to decouple that task from my business logic. Okay. In that way, in that similar way, we can reuse sidecar proxy as a secure building block to apply and use that building block in other kind of application in other part of my organization. Okay, in this way you avoid waste your time, your efforts, writing or duplicating the code. Okay. Conclusions: adopt a proper PKI tooling that has a proven mature API. In this case, I'm using small steps certificate to generate certificate for CADI on demand that expose a ACME interface or a proper interface, in this case one API layer, to generate certificates on demand when the CADI is running automatically. You can inspect all details and handshake how works that inspecting the logs of CADI. Okay. Yeah. What happens? You want to use let's encrypt services. Yeah, you can do it. But the problem is you have to open specific ports for your microservices to get that certificate from internet. As you know, Let's Encrypt is a public service which provides certificate. What happens when you are running your application for your in your internal organization? Yeah, you have to open a specific port that sometimes is not possible. What happens? You want implemented to implement a PKI, internal PKI in your organization. Yeah, you can still using CADI and configure CADI in order to retrieve certificate from your internal certificate instead of use Let's Encrypt. Okay, there are some a bunch of solutions which provide that friendly API like a HashiCorp Vault, small steps certificates. What else? Cloudflare SSL is other powerful tool with mature API in order to create your own internal PKI. Okay, adopt sidecar proxy. That is the main recommendation for this kind of scenario. CADI server is lightweight proxy, written and go without dependencies, powerful API. You can configure Docker, many CADI Docker instance. You can inject the configuration in real time. It's not necessary to kill the process and restart again the process. You can load that configuration in order to create to expose your microservices in without disruption. What else? Sidecar proxy. Yeah, you have other kind of proxy. You have HT proxy. You have NGIX proxy also. That they are not prepared to be used as a sidecar. You are using working using microservices architecture. I recommend to use tiny, lightweight proxy like a CADI Envoy proxy also. There are most available proxies available for microservices. Yeah. Technically, you can use HA proxy or other solutions similar to Engine or even HTTP Apache HTTP reverse proxy. Well, there are many solutions. Okay. Other point, conclusion is secure data plane is your service mesh must MVP. Yes, you are obviously you are using sidecar, adopting sidecar. You are building your data plane. You are building your network for your microservices. That is the MVP for your service mesh architecture. Instead to implement monolith or big bang solution for microservices, adopting STO or Tanzu, for example, solution, a commercial solution for microservices, I recommend to start working in the simple solution, building your secure data plane as initial version for your architecture, for your microservices. Yeah, there you have a bunch of solutions available in the market. If you have any question about that, just drop me an email or ask me through Twitter or something like that. Okay. We spent many. Thank you. Okay. Questions. Okay, have some message. Okay, cycle pattern. It's right. Yeah. Well, this is your data plane. Yeah. Question. Sidecar pattern. In this case, you need the service mesh. Yeah, service mesh is a commercial concept. There are many initiatives. This is a buzzword, but I recommend start working in the simple scenario. That is, build your data plane. Without data plane, it's impossible to build a control plane. Without control plane, it's impossible to get a proper service mesh. Then focus, put your effort building a proper data plane, adopting sidecar pattern. Okay, that is the recommendation. Other question more is in. Okay. Okay, more questions. Yeah, many people use Envoy as sidecar because has a powerful API and provide by default a nice feature to make to get telemetry. So you want to monitor all traffic and tracing over your microservice architecture. Obviously, Envoy is suitable for this kind of scenario. But I know I need to check the information, the configuration of documentation of CADI. I think that they provide other mechanisms to get telemetry or get logs or tracing. That information is useful when you want to get the best performance for your microservices. But from security point of view, that for me is fantastic because they provide by default TLS. That is the de facto protocol used when you are implementing microservice architecture. Services or implement Acme protocol is fundamental. You're able to manage CADI through a special API, security API. You are able to orchestrate and bring CADI in your Kubernetes infrastructure and create different instances of CADI and create your own data plane. Yeah, you can call the service mesh, obviously, but the most important part in your architecture is your data plane, no your service, your control plane in this case. Yeah. What happens if Docker contains stopwetty? Yeah. Yeah. I'm going to get a lab. Okay, fine, lab. Okay. Thank you. Thank you. Yes. Abdul, the rat dev, Lister, Cooper. Thank you. Yeah, yeah. Sometimes the wetty terminal